organic chemistry again. So we're going to discuss next about functional groups. Yeah. So if they ask you, or maybe I think some of you have asked me what is functional groups, right? Uh, Functional groups you can say is a group of atoms that have a similar chemical properties. So the example of functional groups is like alkenes, alcohol, carboxylic acid, and ester. Before I go further, I have to go with alkenes still. And the continuation of that video is Markovnikov rule. Markovnikov rule is something beyond IGCSE. So you want to understand it, then that's good. You don't want to follow this actually for IGCSE level, that is fine. Okay, for example, you have the reaction between propene and HCl. And let's say I draw the propene, it's like this, for instance. Guys, this one will be the last time I'll be teaching the organic chem. Yeah. So if you have any questions, you can ask it right now, okay? Okay, so if you want to follow the right way in doing the organic chemistry is you're gonna open the double bond first before you do the addition things in. Okay, when you want to add the HCl, usually the HCl are separated into two atoms, yeah, H and Cl, right? So Markovnikov rule state that the hydrogen atoms, if you want to add any hydrogen atoms here, the hydrogen atoms should be added with a group of with the C, with the carbon atom that have more H atoms. So which carbon atoms have more H atoms? Left, middle, or right? If I say the left one, do you understand? The most left C is attached to two hydrogen atoms, while the middle C is only with one hydrogen atoms. So means right the result.
So the right one?
The right one doesn't have the extra like,
Oh,
so you
okay.
can just ignore it. Okay, so the result that you get for those who have learned about the namings would be 2-chloropropane. But however, in IGCSE, if you not follow Markovnikov rule, and if you write down the product as 1-chloropropane, that one also would be fine. That one also will be fine. So until here, so let's say, for example, we talk about same functional groups here. So if they come from the same functional groups, right, they definitely have the same general formula. They will have a similar chemical properties. They will show the same trend in the physical properties. What is the same trend in the physical properties? For example, if I talk about alkenes, if the number of C is getting more, the boiling point increases. Because why? Because the van der Waals forces are getting stronger. So it will apply to all of the alkenes. It will apply to all of the alkenes. I mean, if the C is getting longer, it always getting higher, the melting point and the boiling point, for instance. So that is the same trend in the physical properties. So until here, you guys have any questions? The next one is alcohol. So uh, first we talk about the solubility first. From methanol to butanol actually is soluble in water. However, butanol is some textbook they write is a partially early. So if the number of the carbon atoms in an alcohol is getting longer, the solubility decreases. Is there any reason in this? Yeah, there is. So what make it to be soluble is actually the hydrogen bond. It is soluble because it could form a hydrogen bond. The hydrogen bond is being formed between the H atoms in the OH with the water molecule. So for those who just learn, alcohol is written as ROH. So for example, if I say methanol, methanol means 1C. So CH3OH. If I say ethanol, ethanol means CH3, CH2OH. So that is OH is like a functions of alcohol. The general formula is given by CN H2N plus 1 OH. So you can count all of the H or the C will follow this pattern. What I mean by hydrogen bond is beyond IGCSE. So your hydrogen atoms in the OH bond a hydrogen bond. That's why they are soluble. When the carbon's atom increases, when the number of carbon atoms increases, turn out the van der Waals forces are getting stronger compared to the hydrogen bond. So this one make it become more to non-polar. That's why it cannot dissolve well in water if the chain is getting longer. Okay, second thing that you need to know is if you do combustion, the product is always water and carbon dioxide, right? Also, still about alcohol, but more specific. Let's say to produce ethanol. To produce ethanol, there are two ways. The first one is by using fermentation, right, of glucose. This one, the catalyst is yeast, but when the ethanol concentration is higher than 15%, the yeast is denatured. So you have to keep on adding the yeast. Second ways to produce ethanol is from what you learned last week. You add steam to ethene, hydration of ethene. So usually in IGCSE, they will ask you the advantage and the disadvantage. If you do fermentation of glucose, right? If you do fermentation of glucose, the advantage is this one consume a lower amount of energy and then is renewable. The advantage of doing hydration is you can get a pure ethanol. In the first process, the ethanol that you produce, right, is being mixed up with the glucose, so it's not pure. And then also, beside that, right, the first one have a disadvantage here because the yeast will be denatured, so you have to keep on adding the yeast. So the disadvantage is the ethanol is not pure. So the advantage is it consume a higher amount of energy, and I don't think you can do it in a laboratory scale because you have learned about the temperature, right, from the previous recording. Yeah, so far until here, any of you want to ask questions? No. Okay, let's take a photo of this. Yeah. I will keep on talking because this is like a revision for some of you. So I don't want to keep it like too long. No questions, right? Okay. Okay, still about alcohol. Yeah? The fourth point that you have to know is oxidation of alcohol. So keep in mind, actually primary alcohol will be oxidized into carboxylic acid. And this is the basic that you need to know for IGCSE. Not all alcohol can be oxidized, but that questions never will be asked in IGCSE. So whenever they ask you about the oxidation of alcohol, the product will be carboxylic acid because IGCSE only learn about the primary alcohol. Okay. What is primary alcohol? Primary alcohol is mean the C that bonded with the OH, right? They are surrounded by one alkyl group. R is alkyl. It can be as long as you want, like CH3, CH2 can be as many C as you want, but then the C only can be surrounded by one alkyl group. So this one is primary alcohol. So for example, if I draw the C that carry the OH with this format, this one not primary alcohol. This is secondary alcohol. And the product is different, but I don't want to discuss about this. Okay, now I go back to the oxidation of alcohol. So whenever you are being asked for that, the answer is carboxylic acid. So for example, I have a propanol. Propanol, if you oxidize it, it will become propanoic acid. For those who just learned, propanoic acid, the functional group is COH. It will be changing from CH3, CH2, CH2OH. This is alcohol, right? If you do the oxidation process, it will change it become CH3, CH2, and the last C. This is how you're going to draw the COH. So if propanol, you do the oxidation, it will become propanoic acid. What is the agents? What is the agents, the oxidizing agents? Acidified potassium 7 manganate or acidified potassium 6 dichromate. And it will be better if you heat it up also. Any students have questions until here?
No.
No. The next process about alcohol is I want to talk about dehydration. So dehydration is the reverse process of hydration. The recording that you watch, there is a hydration of alkenes, means you add with the water molecules and it will give you the alcohol, right, as a product, right? So if you dehydrate alcohol, it will give you alkenes and water. So if alcohol, you remove the water molecules out, it will give you alkenes plus water. What is the dehydration agents? There are several. The catalyst, I mean. The first one is can use aluminum oxide and plus heat. The second one, you can use concentrated acid or phosphoric 5 acid, for example, at 170 degrees Celsius. So there are two catalysts that you need to know. So you will get the alkenes. Let's say, for example, the first one, the first one is usually doable in the laboratory scale. So this one is the setup. You will collect the gas through water. You will collect the gas through water. If a teacher asks you why you collect the gas through the water, because alkenes are not soluble in water. The gas that you can collect through the water have to be insoluble in water. So alkenes is insoluble in water. This one you apply the heat at here, and this one is the catalyst. This is the Al2O3. And for the alkenes is the one that you mix with the cotton wool usually at here, or in here they use the alcohol, I mean ceramics wool. So it's a ceramic wool that you put with some alcohol, but then you don't do direct heating because the one will be explosive if you do the direct heating. So we avoid that also. So far until here, do you have any questions?
Sir, how about the concentrated phosphoric acid? Do we use both catalysts or just one?
You choose one only. This one I just tell you that there are two catalysts that you can use.
Okay.
For those who just learn or at first not really understand, do you have any questions until here?
No.
Don't have. Okay, I continue. Yeah. Now the next thing that I want to discuss is carboxylic acid.
Sir,
So carboxylic, yeah.
and go back. I haven't taken a picture.
Okay.
So, is concentrated sulfuric acid not one of the catalysts for dehydration?
Can also actually they write any acid say.
Oh,
So
I
thank you
see.
for asking. It can be any acid. Okay. So for the dehydration, maybe now you haven't write down the notes, right? You can write first anywhere at your paper there. It can be any acid as long as it's concentrated. Okay, carboxylic acid is weak acid, yeah. So just now you already see, right? Carboxylic acid must have something like COH here. So yeah, like a normal acid, it is soluble in water. And then what I need to discuss further is you can use carboxylic acid and you add it with alcohol to produce ester. So the catalyst is concentrated sulfuric acid, and also actually need to heat it up. Okay, so for example, I use propanoic acid. So this is propanoic acid. And then I add with alcohol. Let's say I add with ethanol. Ethanol means there are 2C. Okay, this process is reversible. This process is reversible. And if you proceed forward, the process is called as esterification. So you produce ester. For those who just learned, I suggest you to remember that the side product is water. You don't need to stress out about how to get the ester product. You just have to focus on getting water. So how do you get the water molecules? You should remove the OH from the alcohol, and you remove one of the H from the COH. So the format is like that. You should remove the OH from the alcohol, and you should remove the H from the carboxylic acid. So whatever that it leave you at there, you rewrite it. That is your ester. So BCH3, CH2, COO. Then you continue with the CH2, CH3. So once you remove the water molecules, you rewrite everything as a chain. So this is the ester. So ester has a functional group of COO. Alkene have double bond. Alcohol have OH. Carboxylic acid have COOH. Ester only COO. What is the other thing that you have to be aware of? When you have the C double bond O, the one is coming from carboxylic acid. The C double bond O to one side is coming from carboxylic acid. Okay, now before I talk about that, how you gonna name your ester? To name the ester, you have to remember always alcohol plus carboxylic acid. So your alcohol is ethanol, so ethyl. Your carboxylic acid is propanoic acid, so ethyl propanoate. So it's always end with ATE. Okay, so for example, I name an ester. I give a name, let's say ethyl propanoid. So the the ethyl is representing, sorry, propyl ethanoate. Propyl ethanoate. So the propyl is representing the alcohol, and the ethanoate is representing the carboxylic acid. Okay, how can it be helpful? Well, if you want me to draw ester, I always draw the functional group first. And this one is flexible. Yeah? You can write COO or you can write OCO, that is. But I just like purposely flip it. Yeah? Okay, what I gonna restate that here is the C double bond O, the C double bond O to one side is representing the carboxylic acid. What do I mean by to one side? You cannot go across the O. I repeat it. You cannot go across this O. So to one side means to the right, like this. The carboxylic acid come with the term F, right? How many C do you have at F? It means 2C. I repeat it. F means you have 2C. Now you have one already, right? So add one more, CH3. Okay. On the other side, you have to take it from the alcohol. Your alcohol is prop. Your alcohol is prop. So how many C are there?
3.
So your alcohol is, this is the ester drawing here. CH3, CH2, CH2. Any questions until here?
No.
No. Okay, you can take a photo. I'll give you small questions.
Sir, I haven't taken a photo.
Here, ready?
Yeah, thank you, sir.
No problem. Okay, you try to do this directly now. For part A, both have to have 2C. Alcohol and carboxylic acid, each of them are 2C. For part A, any question? No, part B, do already. Alcohol has 3C, another one have 4C for the carboxylic acid. Anyone want to ask questions?
Sir, I cannot get the
Clear.
propyl. I cannot get the B.
You have drawing?
Yeah. I cannot get the.
Okay. You
I cannot get how to combine the OH and H.
with the double bond one to one side, you must have 4C because that is the carboxylic acid. From the O to the other side must have 3C. It is flexible. You can still draw the COO like this. It's not a must to be OCO. But the double bond C to one side, the total have to be 4C because that's the carboxylic acid, butanoate. So there are 4C.
Okay, sir.
The other students have questions? No. Okay. Okay, so just now I told you esterification process is reversible. Esterification is when you proceed forward, yeah? When you have the alcohol and carboxylic acid react together to form ester and water. Okay, so if you want to proceed backward, we call that as hydrolysis. So there are two types of hydrolysis. The first one is acidic hydrolysis, where the catalyst is dilute acid plus heat. So unlike esterification, to proceed forward, the catalyst have to be concentrated sulfuric acid and you heat it up. To proceed backward, dilute acid and heat is enough already. Dilute is enough, not a must to be concentrated. Okay, if you did it backward, means it will give you alcohol and carboxylic acid back. So for example, if I have a propyl ethanoate, so it will become a propanol ethanoic acid. The next one is the second types of hydrolysis is alkali hydrolysis. So you will be using dilute alkali and heat. It does not give you carboxylic acid back, so it gives you alcohol and salt. So for instance, if you hydrolyze a propyl ethanoate, you still get propanol, but instead of getting the ethanoic acid, you'll get something like sodium ethanoate. The question is why I get salt instead of the carboxylic acid. So try to understand this step well, okay? Actually, we get a carboxylic acid. Well, however, the carboxylic acid will react with the alkali. That means like a neutralization take place. So you will have salt and water. That's why the product right now is no longer the carboxylic acid, but it will become like a sodium ethanoate. Why suddenly sodium? It means the alkali that you use is NaOH.
So I thought catalyst doesn't get used up.
Sorry?
I thought the term of catalyst is like it doesn't get used up.
It won't be significant change because however your acid is weak.
Oh, okay.
Do you have any questions that you want to ask until here? Okay, no, yeah, I go with cracking, if like that. So the next process that I want to talk about is cracking. Cracking is breaking down long chain of alkanes. Yeah. So you only can break down alkanes to form alkenes, or hydrogen gas. So for example, you have a long alkane, let's say C12H26. The product can be any, as long as you add the C and the H up, they have to be the same between left and right. So usually there are three options. You can form alkenes, alkanes, or H2. But you don't really need to be stressed out with the products because the key is they will tell you and you just need to make sure it's balanced between left and right. Okay, so there are two types of cracking, but then actually in IGCSE, we only learn about thermal cracking. So thermal cracking from the term means you need a high temperature and high pressure. From the term itself is a thermal, so it means you need a high temperature and high pressure. How much is the temperature? There's a range, so like from 450 to 700 degrees Celsius, and the pressure is around 70 atm. There is another types of cracking that actually you don't learn in IGCSE, which is known as a catalytic cracking. So catalytic cracking means you will use a catalyst, and the catalyst here is zeolite. Well, however, the temperature still have to be high, but then because you use a catalyst, you will need a lower pressure. You will need a lower pressure, so the pressure is not necessary to be that high anymore. Any of you have questions until the cracking process? Don't have it. Okay. Take a photo already, so I can clear the board. Okay, I still talk much about the cracking here. So you have a crude oil is alkanes here. You're gonna pass the crude oils to heater first. So means you gonna heat up the crude oil. So means it will turn into vapors here. So your crude oil turn into vapor, Then after that, you will pass it to the fractionating column. Yeah? On here, if in industry scale means you have a huge column, right? And then after that, your vapor will condense and giving you several products. Yeah. The one that you collected at the most top, right, is natural gas. Yeah. Because it is the shortest chain, so it has the lowest boiling point. You know, if you do fractional distillation, the one that you collect the first is the one that has the lowest boiling point, right? So the first layer is the natural gas. After that, if you go lower, it will produce it will give you gasoline. Yeah? Gasoline in some textbook they write it as a petrol. Then you have a naphtha. Naphtha, be careful with the spelling. Yeah? PH. Yeah? Naphtha, the function is to make chemicals. Yeah? So every chemicals need naphtha. And then the next one, you will have kerosene. Kerosene in some textbook is the same with paraffin. This one is for jet fuels. And then after that, the next one, it will give you diesel for a diesel machine. And then the next one will be fuel oil. Fuel oil is usually for ships. Yeah? And the next one could be the lubricating oil for means engine, right? And the last one is bitumen, yeah? Or asphalt, yeah? For road, right?
Heavy oil, sir.
Heavy oil, yeah, somewhere in the fuel oil and the lubricating oil. Yeah? Now, this one is in industrial scale. Yeah? This one is in industrial scale, okay? If you do it in laboratory scale, school lab, yeah, I mean, yeah, the setup almost the same with dehydration, yeah. So you still use a catalyst of aluminum oxide, yeah. So the setup is almost the same with the dehydration. You have any questions that you can ask until here? Also, right, if in chemistry, aluminum oxide, some textbook, they write it as a porcelain. So there are different terms like that. So I have the same purpose, the same function. Okay, until here, any question? So if someone asks you what is the function of ester, ester has a nice smell. So usually for perfume, and then you can use it for organic solvent also. Okay. Yeah. So there's the function of ester.